In this video, we are going to talk all about structs, and this is not going to be the only video about structs. We are going to have a few more videos about structs in order to understand them in detail. In this video, we'll cover the basics of structs and how they are used in Rust. So, yeah, let's get into it. So, structs are basically used to group related data, and they are pretty similar to classes in a language like Java or Python. So if you are familiar with those languages, then structs are going to be pretty simple for you to understand. So in order to declare a struct, we use the struct keyword followed by the name of the struct. Over here, we have named the struct user and then followed by two curly braces inside which we declare different fields of data that this particular struct is going to have, and then semicolon and followed by the data type of that particular field. So this is how you declare a struct in Rust. Pretty simple. And then in order to actually use it, in order to instantiate this struct, we declare a reference. Over here we have done that using let user1 equal to then the name of the struct, which is user, followed by two curly braces, and then inside it we actually assign values to all the different fields that we declared in our struct above, and we make sure that we assign only those values which are having the data types as we have mentioned above. So that is one thing that we have to keep in mind. So this is how you instantiate a struct. User1 is a reference which is pointing to an object on heap which is of type user and which is containing all these fields of data. So yeah, this is pretty much it. And in order to later on mutate this data, so once you have instantiated a struct, so then that is mutable and you cannot later on change its value or value of any one field. So in order to do that, in order to change or mutate the values of the instance that we have created, we have to explicitly mention that instance as mutable. That is what we have done over here. We have declared a mutable reference user1 which is of type user, and then inside we have we have assigned different values to different fields. And then after that we can actually go ahead and access any one of these fields by reference name, which is user1 dot the name of the field, which is email, and then we are trying to set a different value to that particular field. So you can do that only if your instance is mutable. And there is one more important thing to note, that even if you want one particular field inside the struct to be mutable, you have to declare that entire instance as mutable. You cannot just declare one particular field as mutable. So that is one thing that you have to keep in mind. So yeah, that is pretty much it about declaring structs and what is the syntax of structs. Now if you're from a language like Java or JavaScript or any object oriented programming language, you must be knowing the concept of a constructor, which helps you to instantiate a particular class. So over here we have declared a function which is pretty similar to a constructor. You can relate it with that. So what a function does is it takes some values, it takes some parameters, and then it returns us a instance of our struct. So over here we have named the function build user, and it is taking two parameters. One is email, which is of type string, and the other is username, which is also of type string. And then it is returning a user instance, a instance of type user. And yeah, inside it, which we are just returning a user instance with the fields assigned to what we got inside the function in the parameters. So as you can see, we have assigned the username to what username we received in the parameters, and email to what email we received in the parameters. And then we can also give default values to some fields. As you can see over here, we didn't actually receive the active and sign in count field in the parameters. We have just given it a default value. So every instance of the type user created by this build user function will have a by default value of the active field set to be true and the sign in count set to be 1. So yeah, you can relate this function to pretty much the concept of a constructor. Yeah, and there is one shorthand that we can use, which is called the init shorthand. Now what it does is, if the name of the parameters that you are accepting in the function and the name of the fields in the struct are same, then you don't have to actually write username colon username or email colon email. Now, in order to reduce the amount of code that you write, you can just mention the name of the field. So it will automatically search for the parameters for a parameter of the same name and assign its value to that particular field. So this is one shorthand that you can use. Now, before actually understanding the struct update syntax, which we are going to understand next, let's actually create this user struct and try to instantiate it in VS Code. So we use the struct keyword, then the name of the struct, then inside it, inside the set of curly braces after that, we declare all the fields. So it has an active field, which is nothing but of Boolean type. Then we have a username field, which is nothing but of string type. Yeah. And then we have a email field, which is also of type string. And then we have a sign in count field, which is of type U64. Now U64 is a number type. There are many different number types, and by default numbers in Rust are of type I32, which is nothing but a signed integer of 32 bits. U64 is an unsigned integer of 64 bits. So there are a few different number types in Rust. You don't actually need to know remember each and every one of them. You can use them pretty much as and when you need, and you need what is your use case and what is your need. And yeah, there are quite a few, and we'll discuss each and every one of them as we go forward through this course in different videos. So yeah, over here we are using a U64 type to store the number. And then let's try to instantiate this struct that we have just written in VS Code. First, let us write the main function. Inside it, let's declare the reference, which is going to be user1. Now let's actually assign values to each and every field. So the active field gets a value of true. Then the username field gets a value of string colon colon from let's say abc123. Then we have the email field, and let's assign it a value of string colon colon from the literal abc at the rate gmail.com, something like that. And then we have the sign in count field. Let's give it a value of 2. So as you can see over here, we have actually created an instance of the type user and given it a reference user1. uh, Over here you can see VS Code can infer the type of this reference. It is telling us that the type of this reference is actually a user, and if I double click on it, then it will actually annotate it and give it a type of user. So yeah, that is what it is. So this is how you can instantiate a struct. And now let's understand the struct update syntax. Now what is the struct update syntax is saying? It says that if I create another let's say if I want to create another instance of the same struct, and it differs our previous instance, which is user1, in only one particular field, and the rest all fields have the exactly same value, then you need not actually go on assigning value to each and every field. You can just assign value to that field which is different from our previous instance, and then you can just do this dot user1. You can just take all other values from the user1 instance and assign it to all those fields which you have not explicitly assigned a different value. So let's try to do that now. Let me declare another reference user2, which is equal to user, and then let me just explicitly change the value of username over here. So let me do that. Username colon string colon colon from the literal let's say xyz123. So this is my username, and then I can just do dot user1. So it will Rust will actually take all other values from user1 except from the username, such as the active field, email field, and sign in count field, and assign it to the user2 as well. So yeah, this is one shortcut that we can use if our different instances are differing in only one or two fields, and all the other fields are exactly the same. So this is what we can do. Then after that, there are something called as tuple structs. Now, what they are, let us understand in detail. So let's say if you want to define a struct, and all the different fields inside the struct don't actually have that much significance, and y- you want to use that struct by the struct name itself. So in such cases, you can use a tuple struct. Now, what a tuple struct is, it's basically a struct, and inside it, we don't actually give different fields different names. We just specify their data types, and then you can actually use this struct via its name, as we have done over here. In the main function, we have declared a variable black, and we are binding it to the value color, and then value of type color, and then we are just providing values to different fields inside this tuple, and we are just giving it a value of 000. So yeah, that is what tuple structs are. When you don't actually want different names for each and every fields, and they don't hold that much significance, such as in the next example we can see, we have declared a struct of which has the name point, and inside it we are accepting three values of i32 types integers. So a point in an xyz plane, we are trying to actually implement that over here. So each and every field inside the struct actually doesn't have that much significance, because every field is going to give us a unit of distance. So we don't need to actually go inside the struct and explicitly name each field like distance from x-axis or y-axis or z-axis. We can just provide the values without the names, and then we can refer or use this struct by the name of the struct itself. So that is one key difference between structs and tuple structs, and tuple structs are also quite useful. We'll see those in later examples. So yeah, and now let's come to the most important part of this video. As you can see in the first example that we discussed, the user struct, the username and email field, we have actually taken them as given them the type of string, and that is why during actually creating an instance of the user type, we had to make a string from a literal. As you can see, we have done over here in VS Code. We are actually making a string and giving its ownership to this field. So we are actually creating a string, and what we are trying to do over here is, instead of giving ownership to that particular field, we are just trying to give it a reference of some string. So in this example, we are same declaring a struct or user of the name user, and then inside curly braces we have declared some fields. But in the username and email field, we are not taking a string. We are actually taking a reference to a string. Now there is one important thing that you need to take care in these types of structs, which is nothing but lifetimes. Now let us first try to code this in VS Code and try to compile this. So this code won't compile, but let us actually see what the error is, and what the compiler is trying to say to us. So let us quickly do that. Let us first write this code and comment our previous code. Now let's define the struct again. Struct user. It has the active field, which is a boolean. Then it has a username. And now instead of the username being a string type, we are actually accepting a reference to a string. So that will be at str. And then there is an email field, which is also again a reference to a string. That will be at str. Now if you haven't watched the previous video about string slices and string literals, then you won't understand what I'm trying to explain over here. So I highly recommend watching that video. So then you might understand what we are trying to form on over here. So yeah, the email is of type a string reference, and then there is a sign in count field, which is also of U64 type over here, same as the previous example, the first example that we did. So the only difference that we have made, the only change that we have made is instead of accepting a string type in the username and email fields, we are accepting a reference to a string, which is the @str type. Now let us actually try to instantiate this. So let me write the main function and declare a reference, and let us assign values to the different fields. So let's set the active field to false. Let's set the username field to actually a literal, which is nothing but, let's say, some username 123, and the email field also to some literal. Yeah, something like this. And yeah, we have one more field remaining, which is the sign in count field. Let's set it to 2. Now let us try to actually save this code and compile it. As you can see, the moment I saved the file, we get two red squiggly lines under the in the username and email field. Now let us actually try to compile this code and see what error the compiler is giving us. We are doing that using the cargo check command. As you can see, the compiler gave us an error. Let us see what it is trying to tell us. It is saying missing a lifetime specifier, and it is showing us that expected a named lifetime parameter. Now, I'll talk about lifetimes in a later video, but the only thing that I would like to say now is, let's say you created an instance of the user type, and let's say you gave the username and email field a reference to some string, and later on, let's say you are using this instance in your code, but what if the strings which the username and email field were referring to, they go out of scope and are dropped, but our user one reference is still being used. So I hope you understood that. I'll repeat that once again. So I have created a user one instance over here, and let's say I'm using it in the future in my code, and inside the user one reference that I've created over here, there are email, and there is an email and username field which is having a reference to some another string declared someplace else. Now here, for simplicity sake, I have just given it a string literal, but they can also contain a reference to some string which is declared somewhere else in our code. Now, what if that string, which is declared somewhere else in our code, goes out of scope? Then the user one, then inside the user one, the username and email field will become invalid, and hence the user one reference will also become invalid. Now, this is a big issue because we might be actually using the user one reference in the future in our code. So, in order to prevent this, Rust actually won't let us do this without specifying the lifetime parameter or the lifetime specifier. So yeah, what that says is ki if you are actually doing this, if inside and struct you are actually taking references to strings, then you have to make sure that as long as your instance is living, as long as your instance is being used inside the code, then these references to some other strings are also valid. If they are not valid, if they are being dropped before our user one reference is dropped, then Rust won't let us do that. It will give us an error during compile time itself. So I hope you understand that. Even if you didn't understand the last part, it is okay. We'll try to build up on it in future videos because lifetimes is a pretty difficult topic in Rust. So yeah, that is all for this video. Let's quickly recap what we did. So we saw how we can group related data using structs in Rust, which are pretty similar to classes in any other object oriented programming language. Then we saw how to instantiate a struct, how we have to give values to each and every field. Then we saw if even if we want one field to be mutable, we have to declare that entire instance mutable. Then we can, actually mutate each field and access each field using the dot operator, the name of the reference dot the name of the field. Then we actually saw a function which was similar to the concept of a constructor in a language like Java or Python, where we were taking some fields as parameters and returning an instance of our struct. and how some fields can be given by default values, so that each and every instance will have these values by default. Yeah, then we saw the shortcut, the shorthand. If the name of the field, if the name of the field and the name of the parameter is same, then you can, prevent writing the same thing twice and just specify the name of the field. And then we saw the struct update syntax. If we want to create multiple instances which are differing from each other in only one or two fields, then we can actually explicitly mention only those fields which are changing, and rest fields we can actually import from some other instance using the dot dot and then the name of the reference, this syntax. Then we actually saw what tuple structs are, how if inside a struct the each and every field doesn't hold that much significance, then we can omit writing their names and just access the struct by its name itself. So that is what tuple structs were. Then we saw a pretty important example, how when we are actually accepting a reference to a string in any particular field and not a string type itself, then we have to take care of something called as lifetimes, because if the reference goes out of scope, then our instance will no longer be valid. So that is all for this video. I know that was a lot of things, and I'm pretty sure you guys are still unclear about the last part, the part of lifetimes, but we'll take that up in much detail in later videos. So this is all about structs. I hope you liked the video. So subscribe so that you don't miss any future updates, and share it with your friends. Thank you.